Right. So, um, well, uh, mostly, well, we're continuing off from last time with the fundamental theorem of calculus type of stuff. So, um, number four, finding the displacement. Um, well, the thing is that the displacement, the way you would like what you would write this as symbolically, would be the difference of these two evaluations of S, right? So this is going to be the difference between the two positions, which is the same thing as displacement. And well, when you have this written, it should remind you of an integral, the integral from 0 to pi, because this is FDC part 2. So you would think of this as being the integral of the s prime of t function, dt. And so, well, you can then fill that in with the actual function and then go ahead and integrate it. So this is going to be -3 cosine of t evaluated from 0 to pi. And from there, you just have to plug in. So I'm going to pull the -3 out and then evaluate. So if I plug in at pi, I would get -1. If I plug in at 0, I would get +1. But because this is an evaluation, we have a subtraction for the bottom term. So get that, which is just going to give +6 feet. So the displacement is 6 feet. Okay. For number 5, well, it's going to work very similarly. So an insect population is increasing at this rate. So what I'll do is I'll call a function p to denote the population. The first sentence is actually saying something about the change in population, which is the derivative. So this is actually saying something about p prime t. Okay, and then it also says p at 0. So it's saying that p at 0 is 100 insects. Okay, well, we want to figure out when we want to figure out the size of p of 10. So p of 10 is what we're after. And well, we know what p of 0 is. So again, it's kind of like it's the same procedure, FDC part 2. This difference is actually calculated from an integral from 0 to 10 of the p prime function, which we then integrate. So this integrating this is pretty straightforward. 0 to 10. And then this is going to give me 2 to the 10 minus 2. But we know what p of 0 is, so we can actually solve for p of 10. So we'll end up with plus 100. So 2e to the 10 plus 98. And if you didn't have a calculator, you would stop there, but we'll just reach for a calculator and get the value for it because you kind of want this to be a number that you can think about. So it would give you approximately 44,151 insects. Okay, any questions so far? No, okay. All right, so for number 6, well, A is to just do as it says and to compute this integral. And then part B is asking you to interpret what this integral is all about. So reading the word problem. But we can just go ahead and integrate this guy. It's not so, well, it's a little bit bothersome, the numbers, but the antiderivative is easy enough to compute. So you would have a 2 in the denominator in addition to the 100, so over 200. And this ends up being evaluated from 1 to, not 100, 1 to 10, okay? So plugging in 10, you get 20 plus a half. And then plugging in 1, you'd get 2 plus 1 over 200. And you could try to subtract this. So you'd get like 18 plus 100 minus, is it minus? Yeah, actually it's not that. Why is it not that? Oh, because when I integrate this, I get a minus here. Okay, so this is minus a half minus, so this ends up being a minus. Yeah. But then this ends up being a plus 1 over 200. And then when you compute this, you'll get 17.505 and gallons for units. Okay, so what does this integral represent? Well, so the W is the rate of water that flows out of some storage tank. So the integral from 1 to 10 is representing the amount of water that flowed out in sum. So you're kind of like adding up all these incremental values. And so this is the total amount of water that flowed out of the tank from time 1 minute to 10 minutes. So we just write that out. This is the amount of water that flowed out from minute 1 to minute 10. Okay. Next, number 7 and then number 8. So these are pretty much the same. Let me know if you have any questions. So 7, C prime is marginal cost, right? So whenever you see the word marginal, that's really just indicating that you have a derivative there. So it's a derivative of the cost. The question is asking, how much extra does it cost to increase production from 500 to 5,000 pounds? So the way we would calculate this amount of increase would be by subtracting these two things. We would normally do C of 5,000 minus C of 500. And so that should remind you of the integral from 500 to 5,000 of C prime. Which I'm just going to fill in what that C prime function is, 0.05 plus 0.001x, and we're integrating up with respect to x, not t, sorry, dx. Okay, so we go ahead and perform this integral. 0.001x squared over 2. And we would want to evaluate this from 500 to 5,000. Now this is like pretty bothersome to do by hand. So instead, the way I would kind of show my work for this evaluation is I would just plug in the top into a calculator and then subtract off the evaluation of the bottom. If you're asked to show work, then like this is kind of the minimum amount of work that it could show, I would say. And then you just go ahead and subtract these two. And put your units. So this is measuring dollars. Yeah. Okay. Now part B is asking something related, but not completely, not 100% related. So it's instead telling you that the cost of 0 pounds is 6,000. So that's what you'd call an initial condition. You're told C of 0 is equal to 6,000. And so, well, it's basically, we are going to perform an integral on the C function, but instead, what what we do is a indefinite integral. Instead of these definite integrals with limits, we have an indefinite integral 0.5 plus 0.001 x dx. So this is going to give us c of x. And then we would have a constant that we evaluate. But in this case, it turns out very easily because, well, you end up with, because we're plugging in x is equal to 0, that's going to give us that only the constant will show up when we plug in. So here we have the general antiderivative. And when we plug in c of 0, both of these terms disappear. We only have c, capital C. Unfortunately, it's the same as our function name. But yeah, this is equal to 6,000. And so the function for c of x in general, or not in general, but in this particular case with this initial condition, the constant is 6,000. So we should rewrite our problem to use this fact. Okay, so that's the function c of x. Okay, any questions? So if you guys don't ask anything, we're going to end pretty early. No? Okay. Right. Well, so the last problem here just involves this graph. And this graph is of the function s prime, and we kind of have to work with s instead. So we're thinking about the integral of this function. So part A is asking to find the displacement from t equals 0 to t equals 6. So just like before, we calculate, what we calculate is s of 6 minus s of 0, right? This would be the measurement of the displacement. And we would think about this as the integral from 0 to 6 of the function s prime. In this case, we don't have a function s prime, we just have the graph of it, right? But so now you think about taking this integral, and what you'll see is that, well, you'll be able to figure out the integral visually. So notice that this triangle and this triangle in blue are the same area, and this triangle and this triangle in green are the same area, which means that overall, like the everything cancels when you take the integral. So the integral gives you the value 0. Okay. So the displacement is actually 0 feet in this case. So that's A. For B, the cutoff is a different time. So instead of going all the way to 6, we stop off at 4. And we want to find the position of the particle. So that's where this initial condition fits in. So we'll end up needing that. But the setup is still the same. If we want to show all of our work, we would set it up by talking about the difference of these two things, relating that via the fundamental theorem of calculus part 2, relating it to an integral. And then we can compute what the value of this integral is. So these two things in blue cancel, but this in green, we have part of it. So a half times 2 times -4, which gives you the value -4. Okay. And we can then solve for s of 4, which is what we're after. So s of 4 is then s of 0 plus this -4. S of 0 is given to us as being 6 feet. So this ends up just being 6 minus 4, which is 2 feet. And so that's it for the problem set. Any questions on anything? Yep. Okay, well, then I'm gonna stop